Hello, welcome back to my channel. So in today's lesson, we are going to learn about trees, graphs, and forest. But first, we're going to see here today the difference between all these three categories of graph in terms of graph, trees, and forest. As you see on the board here, for tree is a connected node, but it's an undirected graph. Okay, all trees are graph, but not all graphs are tree, because these are only undirected graphs, whereas for graphs are both directed and undirected graphs. So now again, for forest is similar to tree, but each component is a tree. Each component of a forest is a tree. And for trees here, we have rooted tree, types of trees, rooted tree, MRA tree, and spanning tree. So for rooted tree here, one of the nodes, it has one node only, which is the root node. So from that node, we have the other nodes. That's why they said this is rooted tree. And for the M array tree is a tree in which the number of children of the root node is the same. For this one, we say is a full M array tree. For spanning tree, of course, this one is wherein the user can reach to all of the nodes. Okay, if you have 5 nodes or you have to visit 5 cities, each of the cities, you can visit each of these cities, but without forming a loop. So no circuit is formed in this one, the spanning tree. So here we can see some diagrams on the board. First, we'll start with tree. So here we have A, B, C, D, E, and F. So this one is a tree because you can see here, you can reach to these nodes, but there is no loop form. No circle is formed within this graph. Okay, so this one is a tree. Therefore, you can say it's an undirected tree, because all trees are undirected. Okay, so now let's see for graph. If we use the same letters here, we have A, B, C, D, E, F, and G. This one is a graph, whereas this is a tree. So now you can see the difference, but this type of graph is undirected graph. This is an undirected graph because there is no connection here that says the flow starts from A to B. There is no direction of this graph. Whereas for this one, again, you can see it's an undirected, but there is no loop. This one forms a loop. A, B, A, D, E, F, G is a loop. It's a closed loop. So that's the difference between a graph and a tree. So for tree, no circuit is formed or loop is formed. Whereas for graph, it can either be directed or undirected graph. So this one is undirected. Let's see the one for directed. We use the same diagram here. A, B, C, D, E, F, and G. So here now we have arrow. You can see the arrow. So this one, the arrow shows the flow of the graph. So for this one now, you can say is a directed graph because it has direction. It shows the arrow. Directed graph. So now let's see a forest here. For a forest, you have here A, B, C, D. An example. This one again, this one is a forest. You can see there is no loop here. No loop is formed. But here, each of these components is a tree. So if you remove this one here, from here to this one here forms a tree. Okay? You can remove each of the components here, it forms a tree. So basically, these are the difference between tree, graphs, and forest. As I said, all graphs, all trees are graphs, but not all graphs are trees, but not all trees are graph. Because graph can be either directed or undirected. Whereas for trees can only be undirected. As you can see here, trees are only undirected. So now let's see an example of this rooted tree, M-array tree, and spanning tree. So here we are just going to see a diagram of this rooted M-array tree and spanning tree. So for rooted tree, from the word roots, one of the roots here, one of the vertex is designed as the root. So here we can say if we have here A, B, C, D, E, let's say F here. So this diagram is referred to as a rooted tree diagram because the root here is what? A. It can be a full rooted tree if like the number of nodes here are equal to the number of nodes on the right hand side again. So also for M-array tree is just simple. As I said, for M-array tree now, the number of children of any node of each root must be equal to the other children. Okay, so if you have here, like you have here two nodes, A and B, so here again you're supposed to have A and B. Then this again is supposed to have A and B. So this is just a rooted tree. Okay, because one of the node is designated as the roots here. So for M-array tree or full M-array tree, if we have here A, B, C, so here for this one to be a full M-array tree, since the root here is A, then the children are B and C. So this B here again is supposed to have M number of children. So the M number of children here is supposed to be 2 again. So here we have D, E. Then if this one needs children again, it's supposed to be 2. D, E, F, G. Then here again, supposed to have 2. H, I. Then this again supposed to have 2. J, K. So short trees are referred to as fully M array tree. Fully M array tree because it has the same number of children as you can see here, 2. When you go to any node, you move from the root here, A, you come here, B has 2 roots, which is D and E. So also D has 2, F and G. But if you remove this one here, for an example, or this one here, short tree is not a fully M array tree, okay? It's not a fully M array tree because it only has here 2 nodes and this rest here just has 1. Okay, let's see for spanning tree. Mind you, we are going to solve a problem that has to do with this spanning tree, but let's just see. For a spanning tree, as I said at the introduction, you can reach to any node. If you have like 4 cities, for an example, you want to visit these 4 cities. You can visit all these cities without repeating the nodes or without repeating the cities, but no need for you to form a loop. So no closed circuit or loop is formed here. So here is an example of spanning, this spanning tree. Here we see from this diagram, we have here 1, 2, 3, 4 nodes. This one comes here, this one comes here. Okay, then you have this one for an example. So now, based on we have 4 cities, A, B, C, D. You can even add this, E. Okay, so now we want to reach to all these cities without forming a loop, because whenever if you move from this point to this point A, you can go further to the next point. You can't come back to A, but no need to close what? No need to close the loop, because if you come here A, B, and E, you come back to A, then this one is closed. So when this one is closed, you can't do any further because this one is closed. You can't move to another city. So now let's see. Let's break this one into different parts. So first, the best technique here, you can draw these 4 places. You draw these 4 places. So you say that, okay, now I can move from A to B. Okay, no loop. Then B to C. Okay, no loop from this to this. This is one form. Then you have here E at the midpoint. Then this to this here. So you have here A, B, C, D, and E. As you can see, this one is not a closed loop because you can come inside. You can move from here, you come to A. You visit all the loops, all the nodes, okay, without forming a loop. You can draw the same diagram here. We'll say again. You have this 4 again. So this time round, we start from A to D. You can come here. These are A, B, C, D, and E. Again, you can come here to here. You can come here, come to this, come to this. So this one, you can play with this graph, but just make sure no loop is formed. So short graphs are referred to as spanning tree. Okay, this graph you can even change the letters, or you draw another diagram. Make sure that no loop is formed or circuit is formed. Once you are done with this one, then you can visit all the cities or all the nodes without forming a loop. Then it's referred to as a spanning tree. So now we have a problem on the board. that says in the rooted tree below with a root A, the first question here, find the parents of C, the children of G, the siblings of H, and the ancestors of E, and the descendants of B. The second part here says find all the internal vertices and all the leaves. Then finally, the last one says what is the subrooted tree at G? So let's answer these questions quickly and see here. Let's use this points. Okay, so the first question, here from this graph, this is our rooted tree. The roots here, the root node here is A. Is from A, we have all the other roots. So now, from this question, they said, find the parent of C. So this is C. So the parent of C in this diagram is B. Because A, after A, you come to root B. After B, you come to C. So the parent of C is B. So this first question here, Roman, say the parent of C is B. So this is the first point. The children of G. So now let's find here G. This is G. G has 3 children, H, J, and I. Therefore, the children of G are, we have H, I, and J. The next question says the siblings of H. The siblings of H here are I and J. Because they are what? They are the children of G. So they are siblings to H. So the siblings of H are I and J. So the next question says the ancestors of E. So first, you see here, where is E? Here is E. So the ancestors are the generation, the past generation, as you can see here. So first to come from C, B, and A. So the ancestors of E are C, B, and A. So the root node here, because this is the roots. The ancestors of E are CBA, C, B, and A. Then let's come to the second question, Roman 2. Okay, and the descendants, before we come to the last, they said the descendants of B. The descendants of B here are what? C, D, and E. See here? All this node here descend from B. So the descendants of B are C, D, and E. Descendants of B are C, D, and E. The second question here says, find all the internal vertices and all the leaves. Here in this diagram, the internal vertices are A, B, C, G, H, and J are the internal vertices because they form as roots. If you come from here, you come to B. B is a root of C. But here, this one you can see is not a root. I is not a root. L is not a root. M and K are not roots. So also D and E. So the second question here, the internal vertices are A, B, C, G, H, and J. And the leaves are this one is a leaf because it has no children here. So this is a leaf. This is a leaf. So the leaves are F, D, E, K, L, M, and L are the leaves. So the leaves are F, D, E, K, L, I, and M. And M are the leaves. So finally here, the last question here says, what is the subtree rooted at G? So here, the subtree rooted at G, you can see here, the root here is G. So the subtree at G is this. You just remove this graph and draw it separately. So this is the subroot of G at G, okay? So now we can start from G, say H, I, J, here is L, M, and K. So the subroots, this is the last question, Roman 3. This is the diagram. The subroot at G is this diagram. So if you have any question, you can ask on the comment section. Don't forget to subscribe, like the channel, as every week we bring more videos of this content. Okay? Thank you for watching the video.